In this problem, we're asked to perform the operation, what they're talking about here is the addition, of two complex numbers, and in this case, they're fractions. In this, we have to talk about the fractions in the context of complex numbers and how to combine our fractions. With complex numbers, we're not allowed to leave an imaginary part in the denominator, which of course we have an I here and an I here. So I'll need to take care of that. The way I'm going to do that is I'm going to multiply both the numerator and the denominator by what's called the conjugate. It's a process called rationalizing the denominator. In this case, we'll rationalize by using the conjugate. You might need to review those vocabulary words. After I've accomplished that, we will go ahead and combine our fractions. But going way back to when you first learned how to add fractions, the rules have not changed. I will need to have a common denominator. So that'll be part of this process as well. Let's get started. So I'm going to take the number, and again I'm going to multiply top and bottom, the numerator and denominator of each individual fraction by the conjugate. What the conjugate is, in this case, it's the same expression but change the sign. So it'll be 3 plus 2i. Here it'll be 3 minus 8i. So I will do that. I'll go ahead and multiply top and bottom. What this is going to do, it will eliminate an imaginary part in the denominators. If you think of your FOIL multiplication, on the bottom part here we're going to get a 9, and then we're going to get a minus 6i and a plus 6i, but they'll cancel each other out, so they'll be gone. And then we're going to get a minus 4i squared. Well, it would appear that there's still an imaginary part, but if you remember, I squared is the same as negative 1, so I can take it out of the imaginary number category, and it then becomes a real number. The same will happen over here. By multiplying by the conjugates, the imaginary parts will cancel out. In the numerators, I'll still need to distribute. I'll multiply that by I, so I'll end up with an I squared. I'll multiply that by I, which gives me an imaginary part, but that's just part of what goes along with doing this. Same thing here, I will distribute the 2i to both terms in that other numerator. So when we're done, it looks like this. I've distributed the I here and the 2i there, and I get these two expressions. I've gone ahead and multiplied with FOIL these two expressions and these two, and this is what I end up with. Down here in the denominators, I've got these I squared terms, and actually up here in the numerators as well. What I can do there is I can write I squared as a negative 1, so I have a negative 1 times a negative 4, which actually gives me a plus 4. Same over here, I'll have a plus 64. You're going to see I'll do the same here. I'll have a plus 16, and here I'll have a minus 2. The I squared essentially just changes the sign is what it does with us. So I end up with this. Notice down here in the denominator, I'll be able to now combine them to be a 13. Here I can combine them to be a 73. And I've accomplished the first part of the problem. The first part I told you we had to remove the imaginary component of the denominators in both these positions here. That's done. Now, just dealing with fractions, I'll need to get a common denominator. If you remember when you work with fractions, if you can reduce and find like parts, that's great. In this case, really there's none that we can really work with here. So the simplest thing is just to multiply the left side top and bottom by the 73 and the right side top and bottom by the 13. That'll give us a common denominator. So I'm going to do that. I will have to distribute to both terms here and to both terms here when I do this, but I'll at least have a common denominator. So I went ahead and did that. Common denominator is 949. I got some big numbers here, but it is what it is. I can at this point go ahead and add them together. My imaginary parts go together, my real parts go together. You never combine them. You can multiply, but when it comes to addition and subtraction, you don't combine real with imaginary. So I will combine those, and I end up with this right here. One fraction. I have now performed the operation, which required me to, again, multiply by the conjugates, find a common denominator, add the fractions together. The only thing I have left to do is this last part here, write the result in standard form. So as a point of review, standard form just means we're going to separate out the real part from the imaginary part. In this case, what I actually have to do is make two fractions again. I'm going to write 62 over 49 as my real part, 297i over 949 as my imaginary part. This then is the answer that we need to use.